Hello everyone. In this lecture we will discuss batch reactor problem. Batch reactor problem. So the problem is in a batch reactor liquid A decomposes into product B. The reaction is zeroth order. The initial concentration of A is 0.5 kilomole per cubic meter. Conversion of A is 30% after 1000 seconds. Assume that the reactor is in isothermal condition. Now what are required in this problem? The rate constant of the reaction, rate constant of the zero order reaction, and what will be the conversion after 2000 second. So this is a batch reactor. This is stirrer. The reactant A in liquid form is converted here in this batch reactor into product B. A is converting in this batch reactor into product B, and this reactor is in isothermal condition. Isothermal condition mean that the temperature in this reactor is constant. Now the equation for the reaction is A is converted here into B in the batch reactor. A is in the liquid form. It is given that the order of reaction is zero order, so n is equal to 0. The rate law for this reaction will be written as minus Ra is equal to K Ca to the power n, where Ca is the concentration of reactant A, n is the order of reaction, K is the rate constant which we are going to determine. So n is equal to 0 because it is zero order reaction in this batch reactor. So K Ca to the power 0 and minus Ra. So minus Ra is equal to K, because anything to the power 0 is 1. Cn0 to the power 0 is 1. So here Cn0 to the power 0 is equal to 1. So now we know that rate is nothing but change in the concentration. Change in the concentration with the passage of time is known as rate. So in this problem, A is converted into B, so the concentration of A will decreases with the passage of time in the reactor. So suppose this is time, this is the concentration of A. Initial concentration is Cn0. With the passage of time, the concentration will decrease. So here minus sign we will put minus sign because concentration of A is decreasing with the passage of time. So it will be equal to minus Ra. Now in place of, suppose this is equation number 1. Now minus Ra from equation number A, minus Ra is equal to minus dCA divided by dt, and this minus dCA by dt is equal to, this is equal to minus Ra, and this is equal to K. Now we can also write this minus dCA by dt is equal to K. Now rearrange this equation, minus dCA K dt, applying limit minus dCA. The initial constant, and this is the rate constant, is K is the rate constant. Now the first step is to determine the rate constant for this zero order reaction K. So we are going to determine this K. K can be determined from this differential equation. So minus dCA is equal to K into dt, and the integral sign. Applying limit when time is equal to 0, then the concentration of A in the reactor will be Ca0. At time is equal to T, concentration of A in the reactor will be Ca. So after applying limit, minus final concentration minus initial concentration is equal to K into time. So Ca0 minus Ca is equal to K T. Now we know that the conversion and concentration are related by a relation that Ca0 minus Ca divided by Ca0 is equal to conversion of A. From this relation we can determine Ca. So Ca is equal to Ca0 into 1 minus x A. So suppose this is equation number 2, and this is equation number 3. Put equation number 3 in equation number 2, we will get. So equation number 3 is Ca0 minus Ca is equal to Kt. Ca0, Ca, this one Ca0 into, in place of Ca we will write Ca0 into 1 minus Xa is equal to Kt. So after simplification this will be minus Ca0 Xa is equal to Kt. So this Ca0 will cancel with Ca0 into Xa is equal to Kt. Now the initial concentration of A is given 0.5 kilomole per cubic meter. So initial concentration is given to us. Ca0 is given 0.5 kilomole per cubic meter. So initial concentration is given to us. The time is given to us. So the time is also given to us. So the conversion of A is 30% after 1000 seconds. So the conversion of A is given to us 30%, and this is the time is also given to us. This is 1000 seconds, and the concentration also given to us. So we can determine the K, the rate constant K. From this K can be determined from this relation. So K is equal to Ca0 is 0.5 kilomole per cubic meter, and the conversion is 0.3, and the time is also given to us. So the time is given to us, it is 1000 seconds. So K is determined from this. So after simplification we will get the K value. Now what will be the conversion after 2000 seconds? So what will be the conversion after 2000 seconds? Now we know from the above relation that Ca0 into Xa is equal to Kt. So what will be the conversion? The K value is obtained in the first step. The K value is given is equal to, the K value is 0.5 kilomole per cubic meter and 2000 second multiplied by 0.3. Suppose its value is given, is obtained X. Suppose its value is X. Now we are going to determine that what will be the now the second part is conversion after 2000 seconds. So conversion after 2000 seconds can be obtained from this relation. So conversion is equal to Kt divided by Ca0. The Ca0 value is given to us, the K value is also given to us, which is X from this relation. Suppose X. So X after 2000 seconds, so it will be 2000 seconds, and the Ca0 value is given 0.5 kilomole per cubic meter. Remember the X value, the unit of X is kilomole per cubic meter into second. So here the kilomole cancel with kilomole, this will cancel with this, second will cancel with this. So the unit of conversion is, there is no unit of conversion, so the conversion will be, suppose Y. So the conversion will be obtained from this relation. So this was just a problem related to the batch reactor. Thank you very much for your attention.